Hello, thank you for your interest and for watching this presentation entitled Anthropological Physics and Social Psychology in the Critical Research of Networks, whose authors are Deborah Antunes, Renato Fabri, and Marília Pisani. I am Renato Fabri. We are members of the Nexus Research Group from Brazil, and this is an invited online talk for the conference on complex systems, the 15th edition of such conference. Our institutional support was given by the Federal University of Ceará, the São Carlos Institute of Physics, our National Council for Technological and Scientific Development, the United Nations Development Program, the Presidency of the Republic, the, Repu- the Brazilian Presidency, and the Federal University of the ABC in São Paulo. We will begin by an introduction to our study subject, which consists of complex systems whose components are human beings or human individuals, and to our standpoint in such research. We'll then move on to conceptual considerations and to reporting some characterization of such systems through topological stability and linguistic specialization. This will lead us to a discussion of types of networks, groups, and participants, and we will shift then to experimenting in such a system, which will lead by its turn us to a problematization and conceptualization in what we are calling anthropological physics. We'll then perform or try to perform a small percolation experiment and finish the presentation with some thoughts about metasensors and inequality, and closing words with a focus on the implications for scientific knowledge and for the empowerment of the individuals of all these topics, of all this discussion. So, our research subject consists of complex systems whose components are human beings or human individuals, as we said before. We're particularly interested in characterization, classification, and experimentation in such systems because of the potential prejudice of these procedures in such systems and the critical discourse that they uh, uh, incite, they give insight to. And also to pushing boundaries where we find proper, as we will see in some experiments. We take the standpoint of both the researcher and of the human being, which we are components of these systems that we are studying. And this takes us sometimes close to anthropology, which we will see in further details in some slides. Now, let's get a little bit less abstract what we are talking about. Think about the complex system of this conference, of all the individuals that are participating in it. Or think about this presentation, all the human individuals that are taking part on this presentation. I think of this as a complex network. Or being a little bit less abstract, think about the social networks from Facebook, Twitter, email lists, or ParticipaBR. It's a participatory portal from Brazil. This is a friendship network from Marília Pisani, one of the authors. All the dots here, all the vertices are friends of hers and of her. And if they are connected, they are friends. So this every component in this complex system are individuals. Another good example is given on this table where we have some networks being analyzed with respect to some measures for comparison. And two networks are from Twitter. This first network is mine, and it's my friendship network, and these are other networks from other places, and we are comparing the measurements from them. There's our networks whose components, whose nodes are individuals, represent individuals. This is another example from an interaction network derived from email lists, where it's evolving a long time, and these nodes represent also individuals that are exchanging messages through emails. This last example is by some scripts for processing data, open data from Participa BR, that participatory portal we talked about some slides ago. And we can see here some ranking of the users and also their textual messages. So we can relate and measure the users and the activity. So we will now make some conceptual considerations about the research we are performing and move on with our roadmap. Well, the cultural industry is a very recurrent uh, uh, concept in our research because it's a trace of the late capitalism. It's a deep trace of the late capitalism. When the industry takes on the free time of the laborers and it relates directly to ticket and stereotype thinking and prejudice. And there also are very interesting thoughts and literature about changes in human species itself with the advent of the radio and the internet. So we take the authoritarian personality work by Adorno and collaborators as a strong paradigm for us because it's a research between science and social critic, and we find it a fit for the needs of our time. That's about it. It's really brief about what the cultural is about for us in our research. We feel we hope we leave a lot of room for questions. So there's another conceptual consideration about about a friction, a constant friction in this research, which we can symbolize by physics versus cultural anthropology, because physics has a very strong tradition of considering, of valuing knowledge as independent of the observer or the researcher or the reporter of the knowledge. And cultural anthropology, on the other hand, acknowledges this dependency of the knowledge from the observer very much. It acknowledges a lot. So there, this is a constant friction and we'll get in a little depth in this conceptualization in a couple of slides. Last consideration I want to make is about complex systems and complex networks. For our goals, complex systems definition as systems, sum of the parts is more than whose whole is the more than the sum of the individual parts is okay. And we take the stand that complex networks are complex systems represented or modeled as networks, as graphs. And the usual conceptualization that complex networks are large graphs with non-topological characteristics is not really fit for us because we often are interested in small networks, and this non-trivial topological characteristics is a very fragile concept, like the Erdős-Rényi network. Is it trivial? No. And the scale free? No. Well, their definitions are boiled down to the distribution function they follow, and well, we will leave some room for more thoughts on it, but that's what we think. Now, I want to characterize these systems that are composed by individuals by it their representation as interaction networks. And there is a severe temporal instability detected in such systems with respect to the topological measures in principal components, as we will see. The fraction of participants in hub, intermediary, and peripheral sectors, and with respect to the patterns of activity along time in all time scales. Take for Let me show a little bit of the mathematical framework needed to reach these results. Consider k, the degree or the number of edges connected to a vertex, and p of k as the chance of picking a vertex with degree k. And if you compare the scale-free and the Erdős-Rényi model with the same number of vertices and edges, there are two intersection points which you can use as boundaries to define or observe the three sectors: the hub sector, the intermediary sector, and the periphery sector. If you observe the fraction of participants that fall in each of these sectors, you see that it's very stable along time. Take, for instance, 1,000 email messages and make this comparison and find these three sectors and shift these 1,000 messages around. You will see that the fraction doesn't really change. It's very, very stable. And it's only 1,000 messages. It doesn't really usually reach 200 participants. It's usually less than that. It's a very small network for complex networks parlance. Also, if you measure centrality measurements and metrics and symmetry metrics and clustering coefficient in each of these snapshots, you'll see that they don't really change. If you take the mean and the standard deviation of these principal components, of the contribution of each of these measurements for the principal components, you see that the standard deviation is very small, and the first principal component is related to centrality measurements, the second principal component is related to symmetry measurements, and the third principal component is related to clustering coefficient. Plus, the diversity or the dispersion or the variance related to each principal component is very stable as well. The third characteristic is the activity along time that we said. Take, for instance, activity along the day. We have a peak between 11 and 12 o'clock, and the most active half of the day is the second half, and the afternoon is the most active period. Oh, okay, this is the same for every interaction network we analyzed, almost every interaction network, especially email interaction networks. And other time scales exhibit other patterns, such as weekdays exhibit the pattern that weekend days have half the activity of a regular weekday. And with this stability, with this characterization, we can talk about some linguistic specialization. We can make statistical tests on the texts produced by each of these sectors. Take all the text from peripheral sector, all the text from intermediary, all the text from the hub sectors, and make some statistical tests on it. We can define a difference measurement for the texts produced in each of these sectors. And what we find in the end is that the difference between texts produced in the same network but in different sectors is greater than the difference of the texts produced in different networks. Even if we take only one sector, we have a greater difference in the same network. In other words, we have a greater specialization of language in the same system but in different sections than if you compare the same sections of different systems. Well, this leads us to think about types of networks, sectors, and participants. Let's look again at this graph that we're using. We can carry on the type of the sector to the participant that falls in the sector, right? If a participant is on the hub sector, he's a hub. If he's on the intermediary, he's an intermediary. If he's in the periphery, he's a peripheral participant. And not very intuitively, this has two attenuants of being potentially a potential of having potential for prejudice. The participants change their sector constantly. Also, the participants change their sector when the system considers changes. For instance, in my family, I'm a hub, and lots of my friends are intermediary and periphery in my family. Likewise, there are hubs in their family, and I'm peripheral or intermediary. I tend to be in their family, peripheral, intermediary. And not very intuitively, if you categorize the network, if you classify the network, like here we have each dot is a network, is a email list, and on one axis I have the participants, in the other axis I have the messages, and the third axis I have the threads. And we have so many threads when we have very few participants, and that we simply don't have such a great number when we have lots of participants. We can use this to classify the email lists. And this would yields a stable classification of the participants. And this has more potential for prejudice in this respect than this classification that changes along time and along different systems. Let's shift a little bit on experimentation in such systems now that we know a little bit of how they are. Take, for instance, this this Facebook post where Vinicius Bras Rocha cited almost 65 persons, people, and many people talked about it. So he's gathering and making fusions of information. Liliana Moiteiro, Marcelo Saldanha always do this quite often. And we all might agree that this is not only for diffusion and collection of information, but it's also an experimentation or an experiment to know how the environment or our social network will react to such information. Not only in the time but that the post happens, but afterwards. And this is another experiment where I was going into some Facebook groups, gathering data, and then publishing their pictures as interaction and friendship networks. So this is a collection of such posts, of such Facebook posts. This is an experiment where we found that there was two disjunct sets of friends or groups of friends, one which they were more in the middle of the path, of the shortest paths, another one where they were more close to everyone else. This is very counterintuitive because they are the same when the graphs are very small, like this. Then we systematically sent messages to both the groups, and systematically they react the same way for me and for all other friends that did the same experiment. The between us guys, the guys that were more in the middle of the path, they reacted more promptly, talked about it. The other group didn't respond. And this is the last experiment I want to show you because it's quite important. We activated friends, Facebook friends, one by one, from the ones that had the least number of common friends with us to the ones that had the most number of common friends with us, like zero friends in common to a fifth or a tenth of your friends in common with you. And in three cycles, we activated three times, and we had typical reactions in each cycle. And we had really good results for nurturing the projects and gathering money and partnership with even the presidency and academy and UN and specialists. My partners in this presentation, Marilia Pisano and Deborah Antunes, were started working with me in this diffusion of information. We didn't really know each other beforehand. So this leads us to think about anthropological physics, because we're making physics, we're measuring stuff, we're talking about natural laws, we're finding characterizations and differentiations. Uh, but we are using some arguments from anthropology, right? For gathering information, even. I I'm not experimenting, and my friends are not experimenting in networks that they don't participate in, because it would even be considered wrong to do so. So, what is this? This is my friendship network, and I have uh, this. Each dot here is a friend of mine, and I can argue easily that I'm more uh, this structure than the biological body, the unit with two arms and two legs, etc. For example, I didn't make my clothes. I didn't grow my food. I made it, but I didn't grow it. So uh, this structure is myself in many senses, and I have, and it's natural for me to study it, to see how it reacts when I interact with it. And that is what we're calling anthropological physics in some contexts, especially when we take measurements and we do systematic experimentations. The biggest problem that arises, there are two biggest problems. The first one I already talked about is that cultural anthropology is very linked to the idea that the observer influences a lot in the knowledge that it reports, and physics is very linked to the idea that the knowledge is independent of the observer. And another big problem is that this conceptualization often shock and cause strangeness to researchers, and they tend to report on social physics or social physics and other nomenclature, or even physical anthropology, which is anthropology, not physics. So that's about it. We can talk more about it if you wish. This is the percolation experiment. I'm going to leave this for us to make if we have some time after the presentation, so I can grant that I don't go beyond my time. So let's talk about metasensors. If we do this percolation experiment, if we think about all these experimentations and we think what's happening. Take, for instance, this post. It's about a corruption scandal in Brazil in a university. And we cited some people, and lots of them were replying. And look, we're not even opening other replies. It's really big. So we're gathering information about how to deal with stuff, and information about what we're diffusing. So And here you can find a power law if you count the number of messages each one of the participants sent. This resembles a lot the operation of our sensory organs, with the power law um, uh, appearing in all of them. Actually, power laws are not only important for perception because they broaden the bandwidth of the perception, but they are important even for most physics laws, like gravity itself. Gravity itself, you also have this relation with alpha equal to. So I'll leave you with these thoughts. It's a ubiquitous aspect of power law, which is considered a paradigm of inequality, of extreme inequality in most cases. So I want to focus on some final words about the implications for self-knowledge and empowerment of the individual. Take for an instance the conference organization and its partners, the Santa Fe Institute and the US Army. Consider the participants of these organizations. Uh, Are these organizations part of these participants? Does these participants do they have any right to study or to interact and see the reactions that these organizations have? Well, yes, in some senses, even because there are publicized data and procedures, but there are also limits to this consideration of these systems, of these networks, if one prefers, as part of the individuals. In other words, the participants of these structures have these structures as part of them, and they can interact with them. And this is acknowledged. But there are limits. Which are them, and which are the ideal procedures and publicized data and calls for participation in these contexts? Even beyond, what are the procedures that we have for collection and diffusion of information in goods, for both transformation and resistance, for the needs of the individual? Each context might need a different action. And did this conference staff already start a percolation process or beyond the conference, or does this not even make sense because, of course, it is occurring in percolation process depending on the criteria you have for saying that a percolation is occurring. Recalling that percolation is an abrupt change in the property of a system by a gradual change in connectivity. And this resembles a cyberpunk and cyborg um, literature because cyberpunk has this power reallocation through technological advances, and cyborg literature has a somewhat incorporation of technology in the expansion of the self. So thank you very much. Um, Thank you. Special thanks for to Enver. It was very useful in many occasions. Feel free to contact us at any time. And I wish you all the best. Bye bye.